All right, so here we have subtracting fractions. We're going to start with number one. So in number one, it says, while taking inventory at his pastry shop, Kenny realized that he had a half a box of baking powder yesterday. So I'm going to highlight that. But the supply is now down to 1/6 of a box. So down 1/6 of a box. How much baking powder did Kenny have yesterday? So I know he started with 1/2. And I know he was down 1/6, so he's going to subtract 1/6. I need common denominators, so I'm going to find those by finding my least common denominator, which is those least common multiples, but with the denominator numbers. So I have 2 and I have 6. If you'd like to use the non-listing method, you could also pull them this way. Go, there's 2, and that makes 1, and that makes 3. And my least common multiple is 6 because I'm multiplying my L. So that means my least common denominator is also 6. So when I multiply, that means this fraction, 1/6, is going to stay the same. But 1/2 needs to change its numerator because we changed its denominator. So 2 times 3 gives me 6. So 1 times 3 gives me 3/6. So now I can subtract that I have 6's in the denominators and my numerators are equivalent. So 3 minus 1 is 2. And then we keep our denominator. And 2, 6 are two even numbers, so I know I can divide both of them by 2. So that gives me 1/3. So my answer is 1/3. And how much more baking powder? So we had 1/3 more baking powder. All right, I'm going to go down and I'm going to do number 4, which is our mixed numbers problem, not in a story problem. So when I'm subtracting mixed numbers, there's a chance that you might have to borrow. And I would rather borrow from an improper fraction. So I'm going to do that way. You can borrow from the whole and add the fraction to the top, but I like making it all one. So I'm going to change these, which is going to be a little difficult for 9 and 10/27ths. It's not completely necessary, but I just want to use my strategy. So I'm going to make 9 times 27. I'm going to do that math and get 243. Add my 10 in and get 253. Keep the denominator 27. And then I'm going to make this a little bigger. I'm going to do the same thing to 2 and 2/9. So I'm going to multiply and get 18, add that and get 20/9. Now I already know that 27 and 9 have 27 in common. So I'm going to keep the 27, change the 9 to a 27, which is multiplied by 3, and that gives me 60. Then I can subtract 253 and 60 because I have those common denominators. And when I subtract 253 and 60, I get 193. Now, obviously, we don't want you to leave these improper. So the answer would be 193/27. So I need to divide that back. So you're kind of seeing like sometimes this can be a little messy when we're subtracting and we make them into improper fractions. So if you didn't do that and you just decided to deal with the fractions and the whole number separately, that's completely fine too. But when I divide 193 by 27, it goes in 7 times, and 27 times 7 is 189, which leaves me with 4 left over. So my answer is 7 4/27, and there's nothing you can simplify there. Obviously, you could have done this with just the fractions and the whole number. So what I'm saying by that is you could have taken 10/27 and 2/9 and made common denominators and just gotten 4/27 and then subtracted your 9 and your 2 and got 7, which is the same answer I got. Seemed a little easier on this one, but I wanted to just show a strategy that also works in case you have to borrow, which we didn't in this example.